So sometimes we're asked for this question: can this set of data here be modeled by a function? We're not interested in what the function is. We're just interested in can it be modeled by a function? And a function is a rule. So it's a rule that assigns values to different inputs. So let me write that out. It's a rule that assigns values to inputs. And here our inputs are presumably x, and then y would be the value that would come out of our function. So I'm going to step back a second, and we're going to think about something, a rule. And this may be familiar to a lot of people. This is something that's assigned, described in second and third grade math. This function box. So let's say we had a function box of x plus 2, right? So if we dropped a number in here, the new number would come out, be 2 greater. So if we, for example, if we dropped the number 1 in, the number 3 would come out. And if we dropped the number, so let me circle that, 1, then 3 would come out. If we dropped the number 7, then 9 would come out. And this would be, this is a function right here. This is f of x is equal to x plus 2. So this function box should hopefully ring some bells. Okay, but in this case, right, here are x's, here are inputs. So if we drop 1 into our this particular, if it is a function, if we dropped 1 in, then negative 1 would come out. So 1 would go in, negative 1 would come out. So I just graph that point right here. That's A. And if 2 went in, 7 would come out. And I graph that point here. That's B. So is this a function? Well, let's just think about it as a function box. Can this assignment here be described as a function box? So here, if x is equal to 1, then negative 1 comes out. I should do that in green. If x equals 1, then negative 1 comes out. If x is equal to 2, then 7 comes out, etc. So 3, then 3 comes out, and if it's orange, so that's 4, then 6 comes out. So this is a function right here because there's no confusion. We could assign just by this function box right here, based on what goes in, we could say exactly what comes out. So what's more interesting is what's not a function. So let's go to that next example. So is this function number 2 right here? Let me box this so we're not looking at the other stuff. So right, is this the function? Well, if I drop the number 1 in, a 2 comes out. So let's draw that box again. So if x equals 1, then a 2 comes out. If x equals 3, then a 4 comes out. And it says, well, what if x equals 5? Then a 1 comes out, and then if x equals 3, a 3 comes out. So now the question is, well, if 1 drops in, that's easy. You can answer that question right now. Like you could say, well, 2 comes out. No problem, right? But what if I dropped a 3 in here? This function box wouldn't know whether to I should make it a different color. Let's make it yellow. What if a 3 is dropped in here? Well, if x equals 3, it says that we should have the number 4, but here I have another rule that if x equals 3, a 3 should come out. Right? That's what this is. That's what this says right here. And this cannot be a function. You would blow up this function right here would just blow up. It would just, if you dropped a 3 in here, it wouldn't know where to put it. And how do we see that graphically? This graphically, you can see it by the vertical line test. And remember, a vertical line test is one that goes. A vertical line is one that goes up and down. And you could see that if you put any vertical line here, right here, well, that just passes through 1 point. That passes through no points. That one passes through 2 points. And there is the confusion that 2 points, the number, I'm sorry, x value 3 wouldn't know whether to go to the point the y equals 4 or y equals 3. So this is not a function. Okay, and that's why the vertical line test can show you graphically whether something is a function or not. And you can see it right here. You can't really assign the value 3 to any y value. So the answer would be no, right there. Okay, what about the next one? What about this function right here? Well, this function is okay because you can see it passes the vertical line test, and you can also there's the idea of the horizontal line test, which is kind of the very similar to the vertical line test, and from that, just like the first function, you can see that this is 1-to-1, and the idea of 1-to-1 is that any horizontal line test doesn't pass through more than 1 point. So 1-to-1, you've probably heard this before, and maybe you didn't understand it, means that the function is invertible. And all that means is that you can take this function rule, let me write yes up here. You can take this function rule and you can reverse it, which just sounds like invertible, that you can take this function and based on the y value, you can go back to the x value. So first, let's say we know it's a function, and is it invertible? It is invertible because you can reverse this process. Instead of the function is given any x, there's no more than one y, and invertible means that the opposite function going the opposite direction. I'm sorry, I should put the arrows there. Should do it like that. You can go back the other way. And I hope that was helpful, and I'll try to make another video just like this covering graphs of functions.